This is the second part of this Tivoli Ipal audio interface radio thing. It's back again after the person I returned it to said that the problem still remains, and it's typical actually that these radios they never fail, do they? When you're actually on the bench, but as soon as you get it back to the customers, it's messing about again. So what I've done is I thought I sort of plugged it in. It's got this sort of instability and this sort of motorboating effect, and the volume shifts all around all over the place. So I thought, well, I took it apart, and the output chip was red hot. So I'm thinking, well, there's a fault with the chip. So I replaced the IC, the output chip, and the chip is actually it's a TDA 7056B. It's a Philips IC audio amplifier. Now, I initially downloaded the Philips from the Philips website, the TDA 7056 with no alphabetical letters afterwards. You know, it's just a straight TDA 7056. I was going through the circuit and couldn't find, it didn't seem to match up with anything. It seemed a bit odd. But when I was looking at the audio input line, which is, let me just try and show you, it's pin 3 on the chip here, which is this pin here, there was a DC offset on it. And you could see that the drive unit was being pushed positive, so there's a large DC offset on the output. So I tracked it through. I don't know if you can see here, it's not very clear actually. It's this capacitor here, which is the DC, or what I thought was the DC block to the amplifier. So I removed that thinking it was leaky, which, I mean, these ceramics are never leaky. And it was exactly the same. There was a DC offset on the input. So and eventually downloaded the correct manual for it, which is the B. And this is a bridge-tied load amplifier, which basically means it's two amplifiers working together in antiphase, so they work against each other to give you extra power. Now, it's not as simple as that, because when I was looking at the input, I was thinking, well, I can't understand why it's got a high DC offset. Well, that's partly down to the fact it's got a bridge-tied load amplifier, so it's got an internal reference inside. If you look here, here's the audio input here, and this is the reference stabilizer, so it obviously keeps the amplifier balanced. It's got various amounts of protection in it. I don't know how good the protection is on here. It's got temperature protection and things like that. But it's also got this DC volume control. This DC volume control I initially thought was like a basically what the Tivoli was using for a volume control, but it's not. And I'll show you on the scope in a minute what that's doing. Now, I've looked at the input, and the input looks absolutely stable, but you're still getting a shift in volume, and it's definitely sort of up to this amplifier stage. It's not before, or it's definitely around this amplifier section. It's after the volume control, basically, because the volume control makes no difference to the how much the volume changes. It's just like it's something on the output stage rather than the pre-amplifier stage. Basically, if I turn the volume down, the fault doesn't go away. That's what I'm trying to say. So I've checked all the others. They all look good. The regulation's good. The internal regulator on the Tivoli is working perfectly okay, which is just a TO 220 linear regulator, which takes the input main supply and drops it down to 12 volts. But if you look at this, let me turn the volume up so you can hear what's going on. Now, the trouble is with the automatic level control on the camera, it's very difficult to hear what's going on, but you can hear the clicks and pops. Now, I'm going to look at this DC level volume control, but it should be absolutely stable. Just have a look at that. That's there. And that's what it's doing on the scope. And that's not the audio. That is supposed to be a stable, that's AC coupled at the moment. We're at 20 millivolts per division. You can see it's all over the place. Let's turn the voltage down and slow the time base. Let's put it DC. No, let's leave it AC coupled and increase it to 50 millivolts per division. Now I can hear it's really messing around now. And you see the way it's jumping around? Now that is supposed to be a stable DC programming voltage to set the gain of the amplifier. that's DC coupled now, if I get to the right point. 2, 3, 4, 5. It's not so clear there, and I can see on the camera it's sort of like not so obvious, but I don't know if you can see that level is shifting around all the time. So the problem is, it's not the chip, it's the programming voltage that goes to the chip to keep it at a set gain level. So basically this thing's shifting around all over the place, the gain level's going all over the place, and then eventually the chip goes unstable. Now, I don't know if you probably can't see the drive unit, but every now and then, no, it's not enough light to see the back of the drive cone. Every now and then the chip biases, the speaker biases over hard one way, so it's also got a huge DC offset on it, and that's when this chip gets really hot. Now I put this extra heatsink on here just to really protect the chip, but it's already quite warm now. So I need to try and work out what the hell's going on with this 5-volt control line, and unfortunately this thing's a pig to work on. If you need to get this, that line follows, let me just show you here. Let's turn it off so I don't short anything out. The control line is here. This is pin 5, which does the DC volume control, and that pin there is a link that goes back to here, right under this speaker. Now, this speaker, as you can see, is not. You can't get the speaker out unless you move the board out. Now, you can't get the board out unless you can remove this front knob. One of these knobs will not come off. And the other problem with that is, if you remove that, then the LED that's actually arrow-dighted into the front of the radio will have to be cut out. So we're actually at the stage now where we're saying, is it worth continuing working on this thing? I mean, these things aren't cheap. They're cheaply made, but they're not a cheap radio to buy. So the only other thing I can try and do is have a look to see where that wire goes and see if there's an electrolytic across it or something that's breaking down, possibly. Maybe pull the electrolytic out, I can get the soldering iron in there and just tack an electrolytic straight on pin 5 to the ground 1. Here we go, and hopefully stabilise that gain. But at the moment we're in a bit of a quandary where we're going to sort of try and attempt to pull this thing apart, and there's always that risk of damaging it, or we're just going to ring up the customer, or it's actually a friend of mine, ring them up and say, look, this thing's I can probably fix it, but it's, you know, I don't know if I'm going to damage it taking it apart. Certainly getting that knob off is very difficult. I've got one off, but the other one is very, very stiff. And then I've got to remove the whole thing from the board. I've got to try and break that glue out from that light emitting diode there. So at the moment, it's a bit of a shame really, because it's actually quite a nice sounding little radio, and I know these things aren't that cheap. So that's where we are. This is part 2 of the video. If there's a part 3, it will hopefully be repairing it, and if there isn't, you know, it's been sent back as a BR really. Thanks for watching.